Hello everybody. Welcome to Long-Term Retention with IBM Spectrum Protect Plus. My name is Jim Smith. I am one of the development architects on the Spectrum Protect portfolio. So I deal a lot with Spectrum Protect Plus and Spectrum Protect. Today we're going to introduce the 3-2-1 basic rule of backup and talk a little bit about how offsite and long-term retention fit into that. And then we're going to talk about IBM Spectrum Protect Plus and quote-unquote cloud storage, object storage, and how we are creating copies of data and putting them out on object storage to take advantage of lower cost for longer-term data protection. We'll also be looking at how we're moving data, copying data out to archive storage or Spectrum Protect tape for even lower cost storage for archival purposes. Let's take a step back, put some context around this discussion, and talk a little bit about what's been coded as the 3-2-1 rule of data protection. You've seen this around the industry in the last 3 or 4 years on the internet, and this concept has been around certainly a lot longer than that. But the 3-2-1 rule simply states that we have at least 3 copies of data, 3 backups, and we have that data in 2 different formats, and one of those copies is offsite. We're going to be talking mostly about these 2 different formats and the offsite aspects of the 2 and the 1. We'll see that using cloud object storage, for example, gives you a different format than disk, so that counts as our 2, our different format, and cloud object storage is usually, doesn't always necessarily have to be, but it can be considered as an off-site technology. There's also the 3-2-1-1 rule, which is the modified version of this, which in addition to the 3 copies, 2 different formats, and one of those copies being offsite, we add in an extra one, or one of those copies is protected by an air gap. We're not going to get into the philosophical debate about what constitutes an air gap copy. Traditionalists will tell you an air gap means just that. There's air in between your copies, and that usually means that your second copy is sitting on tape, and there's an actual gap of air to cross between that tape and getting data off that tape. But some people consider object storage to, in a sense, be an air gap. Again, we're not going to talk too much about that and what constitutes air gap, but just be aware that a lot of people, and when we talk about archival storage especially, they're thinking along the lines of creating an air gap. So if we look at the Spectrum Protect Plus ecosystem, and we're going to assume that you understand coming into this presentation the different aspects of the Spectrum Protect Plus ecosystem. There's a Spectrum Protect Plus server, which we're not showing just for simplicity, but we have our concept of the vSnap repository, which is our backup storage, and we might have vSnap repositories across 2 different locations, and these are going to group together in this construct that Spectrum Protect Plus has called a site. And we might have replication, which means we ingest data into the vSnap here in the primary site and replicate that to the secondary site. And this is all disk-based. The vSnaps are all disk-based. Now we're going to talk about making copies of this data out to cloud object storage, and we'll be seeing how that also includes Spectrum Protect. Obviously, we've met the 3. We have 3 copies. We have a copy at our primary site. It gets replicated, and we have a copy at our secondary site. And with Spectrum Protect Plus, we can make a 3rd copy of that data. This is critical to this discussion. This is a 3rd copy. We're not moving the data. We're tiering the data from this vSnap repository out to cloud object storage. We're making a 3rd copy. And this copy could just as well be coming from the vSnap repository on the left. I've just chosen to show it coming from the secondary copy. So obviously we have 2 different locations. Now you could argue again that the 2 represents 2 different types of storage. Theoretically, we're within the boundary of this rule, because if we have a storage failure here, even though this is both disk-based storage, if we had a storage failure in the primary site, that doesn't affect the secondary site. So we've met the spirit of this rule. The second copy, we can also count the 2 up here in the cloud object storage. But also we get our offsite copy. So we have a copy that's off-site. So if there's some event that eliminates both these locations or one of the locations, we have that copy safely off-site. And we're going to see that this off-site copy can be either standard cloud, standard copy, or an archival copy. Really quickly, now this is not a session about replication, but I want to just talk a little bit about replication so that we can compare and contrast replication with copying data out to object storage or out to Spectrum Protect, because there are some very important differences that we have to illustrate, which will help you determine what the appropriate technology is for your use case. Replication gives us, first of all, it's within the context of a unified SLA, so to speak. We have a single SLA that tells us that we have a VM here, and this SLA will instruct us that we're going to back up this VM once a day and keep it for 30 days in this repository, and we're going to replicate that once a day and keep it in the secondary repository for 30 days or 60 days or whatever that may be. The replication is available for all IBM Spectrum Protect Plus workloads. So anything that lands in the vSnap server, whether it's VMware data, Exchange data, Office 365, Kubernetes, etc., it is all available for replication. Now we have an optimized copy of this data, so regardless of the type of data, we're going to do a full once, incremental forever copy of the data to replicate it. This is going to allow us, basically, when we have our 30 days or 60 days, whatever, we're going to be able to directly recover data and reuse data. So restore, for example, a SQL server or Mongo database, or spin up an instance of SQL from this storage directly from the secondary site. You can think of all sorts of interesting use cases to do a backup of a virtual machine, replicate it, and then run a test by doing instant access to that virtual machine, running a test version on the secondary site without having to move the data any farther. So that's the replication highlights. Now let's talk about copying to object storage. When we talk about, in general, copying to object storage, we're really talking about two different concepts. From a high level, it's all the same. We're making a copy of data out to what we call object storage. Object storage can either be, in the first definition, traditional object storage, what we think of traditional object storage, which is IBM COS, Amazon S3, Microsoft Azure blob storage, or we're going to see the introduction of some generic S3 type storage. Or it can be IBM Spectrum Protect. It could be a container storage pool. And we're going to talk more about precisely what that means in later slides, but know that this copy to object storage, when we say that term, that we're talking about either traditional, what we think of as traditional standard S3 object storage, or IBM Spectrum Protect, a directory container pool. Now, the term copy, we used to refer to this as offload. And so let's just take a second and talk about terminology. We have deprecated the use of the term offload. It was confusing because people didn't realize that the light bulb didn't go off, so to speak, when we use this term offload to indicate that we were making a copy of the data. Again, I mentioned this before, people might get confused and think that we're moving data or tearing data like we do in Spectrum Protect. That's not the case. We're making an additional copy of the data to satisfy either a long-term retention or archival use case. So a copy means just that. We're going to copy the data that is independent of the original data. What independent means is, again, very literal, is that copy is independent of the original copy. That means in our previous slide, if we were keeping, let's say, a copy of virtual machine backup for 30 days and we decide to send an additional copy off to object storage and keep that for 6 months, 180 days, the question often comes up, what happens when that original data, the original recovery point, is expired off of my vSnap repository? Well, the answer is very simple. It's that copy in object storage is independent. It doesn't matter if that gets destroyed or expired on the primary vSnap or the replicated vSnap. You have an independent copy. And again, a copy means just that. It does not mean a tearing operation, doesn't mean a move operation. It is a copy. Long-term retention, again, I covered this. I'll just briefly say this again, means either copying it to quote-unquote standard storage tier and object storage, such as Amazon S3, IBM Cloud Object Storage, Azure Blob, or other types of S3, which we'll talk about. Or it means, quote unquote, a repository server, which is simply a fancy word for an IBM Spectrum Protect server with a container storage pool. Archive refers to basically doing the same thing, making a copy, but that copy does not land in standard S3. It lands in an archive storage tier in object storage, such as Amazon Glacier, IBM Cloud Object Storage Archive tier, Microsoft Azure Archive, or if you are targeting Spectrum Protect, that repository server means that it will send data to a sequential tape or VTL storage. So offload, you might see it pop up in the presentation. Well, maybe people are used to using that term for historic purposes. It used to mean copying data off to object storage. But otherwise, we're going to stricken this from our collective vocabulary. So let's just talk a little bit about what happens when you copy to object storage. So we have data ingested. It might have been replicated in our vSnap server. Again, we support all these different S3 object storage providers and Spectrum Protect as a container storage pool as an S3 target. We also use full once incremental forever data movement. So that means that the first VM backup that comes into our repository will send the full VM backup out to S3 or out to Spectrum Protect Plus. And then from there on out, we are only sending the incremental differences. So full once, incremental forever. It's all managed, this copy, through a single SLA. So you have a single policy that dictates how you ingest the data, how long you keep it, how you replicate the data, and then how you copy the data off to object storage. And it's going to enable data recovery and data reuse from this storage. And we're also going to look at the end of this presentation how we integrate this with the concept of IBM Cloud Object Storage, or COS Immutable Object Storage. I want to highlight this because a lot of people might have seen the original offload in the first couple versions of Spectrum Protect that only worked with virtual machine data. So this is a very different implementation. We used to have an offload, quote unquote, offload feature that you could only use with virtual machine data, VE data. Now, the modern form of this is independent. So this will work, the copy operation will work with SQL data, Oracle data, whatever you can ingest into the vSnap repository, Kubernetes, Office 365, etc. And we're not requiring any additional agent software. And we'll talk about the magic of that in a few slides here. But again, if you remember, the original offload is the Spectrum Protect server of VE data, where you had to have VE data movers. This is very different. This is now workload independent, no additional agent software required to make this copy. Now, the beauty of this is that once you have data out into S3 object storage or the Spectrum Protect server, you now can recover that from any site independent of where you have the data ingested originally. So that means if I ingest the data from the primary site and send it to the secondary site, I can recover it from either the primary site or the secondary site. All I need is an empty vSnap server. If I have a disaster, I can create a third site. I can install an empty vSnap repository in my third site, and I can start recovering or reusing data directly into that third site. One of the advantages of putting data out in S3 object storage, you have this recovery that's independent of where your primary storage, your replicated storage is sitting. You can use interchangeably. We talk about copying object storage. It could mean the IBM Spectrum Protect server, and there's really no difference in the use case. It's just that the Spectrum Protect server is acting as an S3 receiver. So we're using the same protocol, S3, to copy data into the Spectrum Protect server. It's just been taught how to read that data from the S3 protocol and write it back to a directory, a container storage pool. Now let's just talk briefly about the data transformations. This always comes up as a question. So how is data being transformed as we move through the stack? We know that from the production system, whether there's a virtual machine data or a SQL server, we have on all workloads, we have incremental forever processing. That comes into the vSnap repository. So only change blocks are being written. That data is optionally compressed. After it's compressed, optionally deduplicated and potentially encrypted at rest. So now it's sitting deduplicated, compressed, and encrypted in our vSnap repository. If we decide to replicate it, we're going to create an SSH tunnel, a secure tunnel, and we're going to send over the compressed bits. So we're going to unencrypt the data, rehydrate it from the deduplicated state, essentially, and we're going to send it compressed over the wire. It lands in the second repository compressed, so there's no compression to do, but at this point, at rest, the data will be re-deduplicated if you optionally have that turned on the replica, and re-encrypted. Now when we copy out to S3, again, this could be standard S3 object storage or Spectrum Protect, we're going to again create a secure connection through TLS. We're going to send over the compressed bits. So once again, it's going to be decrypted, rehydrated from deduplication, sent over compressed, and that's how it lands in the object storage. The object storage, whether Spectrum Protect has deduplication at rest encryption, so it's going to be up to the S3 provider to do any other transformations of that data. We're going to send it and land it in its compressed state, and again, deduplication and encryption would have to be done by whoever's providing that S3 interface. Very important to talk about one use case, which is recovery of the vSnap server, or protecting the vSnap server from failure. If you read the literature about the product, you'll see that we recommend if you want to protect this vSnap server, you should set up replication as the way you protect a vSnap server. What we've been talking about, copy to object storage, is really for making a third copy for long term. It's not necessarily meant for disaster recovery. Inevitably, the question comes up, well, can I use it for disaster recovery? I don't want to build a secondary site. I don't want to pay for a second vSnap repository. I don't want to replicate it. Can I just shortcut that and use this long-term retention, this copy out to object storage, as quote-unquote my DR for my vSnap server? If we look at this question, this use case, there's a couple things you're going to have to consider. First, the RPO, the recovery point objective. And know that the object storage copies only the most recent copy, most recent version in the vSnap repository is sent to the object storage. So that means that if you have a backup job that's running on a daily basis, and every 7th day you decide to copy that data off to object storage, you're only copying the data, that recovery point, on day 7. You're not copying recovery points. You don't have recovery points from days 1 through 6 out in object storage. That's very different than replication, where replication copies all the bits for all the versions and can catch you up on day 7 and copy all the intermediate recovery points. So you're not getting all of your copies off the vSnap server. So that's one consideration. For applications like SQL, Exchange, Oracle that have to periodically send logs, like every 15, 20 minutes, you're doing log backs up into the vSnap server. Those logs that are outside of the daily backup are not copied off to object storage. So you're not going to be able to get that near zero recovery point objective because you don't have those extra logs to roll back to out from object storage. Again, you get that with replication. You don't get that with the copy to object storage. You also want to consider your RTO. The recovery from object storage is going to be generally slower than trying to recover data from the vSnap server itself from disk. And that might not be a big deal if you're recovering 1 or 2 things, but if you're doing a disaster recovery and have to recover hundreds of machines, that could be quite costly from a time perspective. We also have a feature that was recently introduced called vSnap Repair, in which you can repair the data on a vSnap server if that server fails. You can only repair a vSnap server from a replicated copy. I cannot repair a vSnap server from data that I've stuffed out into S3 object storage. So the answer to the question, can I use object storage to protect my primary vSnap repository is generally, it's not recommended that this is the use case. Again, the copy to object storage is really meant for long-term data protection, making that copy that you want to keep for 180 days or 1 year, whatever it is, at a much lower cost. If you want to protect your vSnap repository, you're worried about DR, then we strongly recommend looking at the replication technology in Spectrum Protect Plus. So when you register the storage, it's pretty straightforward. You have a panel here. You select your provider, whether that's Amazon S3, IBM Cause, Spectrum Protect Server, etc. You give it a name, and then essentially what you're going to do is you have to provide your key, your secrets to the object storage, to the buckets, etc. And you have to provide, obviously, an IP address for that storage. So that's all very straightforward. We're not going to cover it here. What I do want to talk about is that there's this concept of S3 compatible storage. So one of the choices you have when you register object storage is to go off the board, so to speak, and not use Amazon S3 or IBM Cause, but use S3 compatible storage. We have a tech note that you can Google if you don't have this link. Does IBM Spectrum Protect support S3 compatible object storage? The answer is yes. This tech note lists the object storage providers, and you can see them here as of today, the 4 that we support. And if you're interested, there's an object storage provider that is not on this list and you want it to be on this list, then we invite vendors to participate and certify their solutions by sending their contact information to this email address. This information about the email address is also in this tech note. Just a quick diversion. We're going to look at the cloud cache and understand a little bit about how this actually works under the cover, because again, inevitably we get questions about, well, how does this actually work? What's going on under the covers? How do you get data to the object storage, to S3? So basically what we do is we have a cache, we call a cloud cache for writing data, and that's a special area on your vSnap. So when you use the blueprints to size your vSnap repositories, there's information about how to size this, and we'll look at that in a second. And what we're doing is essentially a second pool in our vSnap server. So we have the main pool, the primary pool in the vSnap server is where the data is backed up to or replicated to. We are creating a logical second pool. From the vSnap perspective, it believes that it just has a secondary pool. And we're using the cloud cache to temporarily cache writes during a backup operation. So what happens essentially is we have another pool that's from the front end, it looks like a standard pool. So we have some vSnap logic that we use in replication that says, hey, let's take these bits from this pool and replicate them into this other pool. So we're using the same front end technology, but the back end, again, this is not a real device, it's a virtual block device, and all that means is that as these writes come in for the backup operation, they're gathered up into like 16 megabyte chunks, and then when we have 16 megabyte chunks, this block device writes out a put into Cloud Object Storage via the S3 protocol. And again, this could go to the Spectrum Protect server. We're using the exact same protocol. So that's the magic. We're using a virtual block device that translates, it looks like another pool, so we can use replication logic to copy from the primary pool to this new virtual pool. And in the back end, we're collecting data and making puts into Cloud Object Storage. Works the same way in reverse. If you want to recover data from the Cloud Object Storage, we have a reuse request or a restore request. We do a get operation. We collect these blocks in the cloud cache, the virtual block device, and just copy them back to the primary pool. For the SQL application of the virtual machine, the VMware recovery, it appears that we're just getting blocks back on our vSnap server from somewhere. It doesn't understand that these were wrapped in S3 and translated back onto the vSnap repository. SQL agent will see SQL databases and logs that are stored on the volume, and it knows what to do with that data. Our VMware agent will see VMDKs sitting on this device, and it will know what to do with that data. The agent's code VMware code, the SQL code, Oracle code, doesn't have to understand what's happening with the S3 interface. The cloud cache is located on the vSnap server. The size of the cloud cache is related to the size of the vSnap pool. So we're sizing basically for backup workloads with moderate recovery usage. That means we're primarily interested in making this big enough that it's going to handle the copies off to object storage while allowing you to do a few recovery requests. Now, obviously, if you're going to be doing lots and lots and lots of reuse requests simultaneously, then you're going to want to have a bigger cache. It's primarily a disk footprint. The vSnap server compute resources, CPU and memory, are sufficient as is for additional cloud workloads, so we don't penalize you in the blueprints for doing copies to S3 object storage. It's really, you have to have this extra storage. And the cloud cache is automatically created for new installations. And if you want to know more about sizing and expanding the cloud cache, then you can refer to the blueprints. Switch over now to our archive use cases and talk about what that means and compare and contrast a little with what we just talked about. So now we're going to be talking about making copies to cloud archive storage. So this again is Amazon Glacier, IBM Cloud Cause Archive Tier, Microsoft Azure Archive, or the Spectrum Protect server tape or VTL. And what you'll notice in this slide is that this archive copy, it's a copy. The path to this copy is a different path, it's a different arrow than what we just discussed with the copy to object storage. So in other words, there is nothing in common between making a copy to archive and making a copy to object storage. If, for instance, in our previous example, we're backing up data, keeping it 30 days here, replicating it, keeping it 30 days here, and then copying it out to object storage and keeping it for 180 days. If we decide that we're going to monthly make an archive, we're going to copy that data from the vSnap server. We're not going to use the data that's in object storage already. It's a separate path, a separate copy of the data. So there's really nothing in common between the copy we're making for archive and the copy we're making for standard long-term retention. So let's compare it a little bit. Like the copy to object storage, the archive capability, again, is a copy. It's not a mover, it's not a tier. And it can copy the data from either the primary or the secondary, the replicated copy of the vSnap server. And again, there's no logical connection between the object storage copy and the archive copies. They're different paths within either the same SLA or different SLAs. So let's just talk a little bit now about the data format and what this looks like. This is going to be a very different way of backing up the data or copying the data. We saw with the object storage, we were basically using fake replication at a volume level, essentially, at the vSnap volume level, to just copy blocks. We're going to do this at a file level. On the vSnap server, we have a snapshot. Every recovery point, we have a snapshot of data that is in native data format, meaning that if we have VMware backups, we have a bunch of VMDKs. If we have a SQL backup, then there are a bunch of log and database files that make up the recovery point. What we're going to do with that is we're going to compress those and send these to what we call a cold data cache. This is not, again, using replication technology. We're using standard, essentially tar compression technology to tar up these into a certain size chunk and stream that. So this is an in-memory, essentially, compression. And we're going to stream that to the Spectrum Protect server. And it's going to land in, it's essentially a disk, traditional file-based storage pool called the cold data cache. And that is going to aggressively, let's say, periodically, but a very short period, migrate the data from the cold data cache onto the tape. So if we look at the tape or VTL, we're going to see essentially a series of these compressed or chunks of these compressed tar files. When we recover from Spectrum Protect, so we have our data out here on the tape and the VTL, it's in this tar format. We're going to use the S3 Glacier protocol. We're going to make a request to Spectrum Protect and say we want to recover data. And the response in Glacier usually is something like, we don't have the data, you're going to have to come back because we have to move the data from this secondary storage back into this cool data cache. So we'll migrate the data back into the cool data cache. When the data is available in the cool data cache, then it gets copied back via S3, via GITs, to the vSnap server. Now we have these tarballs. We're going to expand them back on the vSnap server, back into VMDKs or MDF, LDF files, whatever the case may be. And then it's basically business as usual. We can recover our SQL server from that snapshot, for example. Now let's just take a quick look then at the intended usage of this, because again, the archive, it's not just a difference in terminology, it's a very different technology that we're using to make that copy. So there are going to be ramifications with the use case. So the vSnap server, replication, again, for operational recovery, including DR. We talked about how the cloud object storage is really for long-term retention because you're storing data out on S3, it's a lower cost media. And the cloud archive storage is really to give you even longer term, and here comes that word again, air gap, gives you that air gap. How do we think about using this data in terms of disaster recovery? Again, we talked about the vSnap server. We're using replication, and that's our disaster recovery. As I explained earlier, we're not recommending for disaster recovery you're using cloud object storage as a way to provide DR. For that reason, archive is certainly not suitable for disaster recovery. For data reuse, so again, this is the concept of I have a SQL server, I want to instantiate a database, I don't want to move the storage off of my backup repository, then having the data in the vSnap server, either backup or replication, obviously suitable. It's also very suitable use case for cloud object storage because that virtual block translation can happen very efficiently for this use case. Now the cloud, this is not suitable. Data reuse is not suitable when we're out in cloud archive storage, protect tape or VTL, because you have to wait. That Glacier protocol makes you wait for data to be read back into a faster tier before you can actually use it. Then let's look at finally the SLA implications. Doing anything on the vSnap server with being backup or replication, that's obviously suitable for frequent operations. This is incremental forever. It means you can do things on a daily, semi-daily basis. The same is true for S3 or copying out to Spectrum Protect container storage pool. Since this is all incremental forever, it's suitable for frequent operations. Daily, semi-daily, 4 times a day, whatever that is. When we're writing out to cloud archive storage, again, S3 Glacier, Protect tape or VTL, it's always a full copy of the data. So because you don't have incremental forever, this is not suitable in your SLA to be doing this on a daily basis. This is much more suited for a weekly or a monthly operation. In fact, in the SLA, you cannot be more frequent. You cannot specify anything more frequent than a weekly archive operation for this reason. Let's take a look at the backup again, just review. We've already seen this picture of the data model. We're going to be rehydrating the data. So we're going to be unencrypting it off of the vSnap server. We're going to be rehydrating it from deduplicated form, uncompressing it, and then from the vSnap repository, and then we're going to run compression in memory, tar it, TLS connection, secure connection, sending over to the archive storage, whether that's Spectrum Protect or Glacier or Cause Archive, etc. We are tarring up full recovery points, which is just a set of all the individual application files. So it's a set of VMDK files for VMware, it's the set of MDF, LDF files for SQL, etc. And we're doing this in place, so there's minimal impact. So you think about, how's this impacting my vSnap storage? Again, minimally, because we're doing these tars and sending this data, putting this data all from in-memory. There is no additional space requirements when you're sizing to do archives, and there's no additional compute requirements. Again, these are for just normal archive operations. Like we saw with S3 object storage, we have to bring this data back into a staging area on the vSnap server, so we can't necessarily restore this directly when we're using the SPP server. If you lose your vSnap server, you can create an empty vSnap server, register that with Spectrum Protect Plus server, and that will be suitable for recovering data from archival storage. Theoretically, we don't have any documented process for this, but theoretically, I told you we're just doing S3 puts out to, this could be Amazon Glacier or IBM Cause Archive. And these are just tar files of data that you would recognize as VMDK files, MDFs, LDFs, etc. So theoretically, you could restore that from cloud directly using S3. You could go write your own S3 interface to query those objects and get those objects, pull them back, and put them back together and untar them. Again, this is only for traditional object storage or archival object storage and not for Spectrum Protect, tape, or VTL. Again, we don't have a document on this, but just an interesting note as we complete our understanding of how the data is formatted, the format of the data at rest, we can understand, we can take that one step further and say this is just a bunch of tar files being put out on S3, then we should be able to get them from S3 without Spectrum Protect Plus intervening, and that's a correct assumption. So here's a quick overview again of the different types of pools that you're going to be creating in Spectrum Protect to achieve these use cases. If you're going to be copying object storage, again, this is through incremental forever. We're going to land in a directory or cloud container storage pool using the S3 protocol. If we are copying to archive object storage, i.e. tape, it's a full backup. We're going to be using the S3 Glacier protocol. We're going to initially land the data in a file pool, special file pool, which is called the cold data cache, and then it's going to be very aggressively migrated out to tape. And once again, two different paths, two different types of backend storage, two different protocols, two very different use cases. Now we have a lot of resources for basically hooking up Spectrum Protect Plus with your buckets that you've created out on Amazon S3 or Azure Blob or Cause or IBM Spectrum Protect. So if you Google this TechNote Data Offload to Cloud, section 1 will provide an overview of how you configure each one of these endpoints, whether it's Amazon S3, Azure Blob Storage will talk to you, walk you through going through the Amazon or Microsoft websites, getting the data you need, and plugging that data into Spectrum Protect Plus. And then section 2 of this document shows you, now that you've configured an endpoint for copied object storage or for archive, it will show you how to create an SLA to exploit those endpoints. All right, finally, we're going to talk about immutable object storage from IBM Cloud. So the idea here is that we have buckets that are immutable. Once you land something in a bucket, you're not allowed to modify until the lock is lifted off that bucket. So essentially what we're saying is that we have a bucket here in IBM Cloud Object Storage that has a retention of 730 days, 2 years. And we're going to connect IBM Spectrum Protect Plus to this bucket and use this as a target for our copies for long-term data protection. The SLA in very, very simplistic terms talks about frequency, retention, and placement. So frequency is obvious. We're going to back up something every day. Retention, the placement is obvious here. We're going to place it in IBM Cause. The retention is interesting because IBM Spectrum Protect Plus is going to tell us, hey, you don't get to dictate the retention in this particular case. The endpoint, the bucket that you've chosen, has worm retention or a lock on it. That retention is 2 years. So if you put data into this endpoint, your retention is automatically 2 years. So we're going to honor basically that retention setting in IBM Cause. And this is unique to IBM Cause. It's not currently supported with any of the other S3 providers or with IBM Spectrum Protect. So that's immutable object storage and SLA policy. So to conclude, send you off with more information if you want to see actual demos of how this works. There are at least three very excellent videos out on our YouTube channel. So with that, we will conclude the presentation. Thank you much.